So hello guys, welcome to the mining Gyan. So today we are going to study the shaft sinking topic. Okay, this is the topic which is very most important in the method of mine methods. Okay, or we can say method of work. These are the basic things which we will discuss over here. आज के इस लेक्चर में जो हम डिस्कस करने जा रहे हैं वो है शाफ्ट सिंकिंग। किस प्रकार से शाफ्ट सिंकिंग किया जाता है, क्या उसके तरीके होते हैं, कौन कौन सी इंस्ट्रूमेंट्स का इस्तेमाल किया जाता है, इन सभी चीजों के बारे में हम डिटेल में डिस्कस करेंगे। ओके, तो आपका इस ये जो है तो एक इम्पॉर्टेंट टॉपिक होता है जिसमें कि हमें हर एक चीज बेसिक चीजें जो है तो जाननी चाहिए, जरूरत है इसको जानने की। ठीक है, तो यहाँ पर हम हर एक चीज के बारे में डिस्कशन करेंगे। अब जैसा कि आप सभी जानते हैं, शाफ्ट सिंकिंग जो है तो आपका एक डेवलपमेंट का तरीका है जिसमें कि आप माइनिंग तक, आप ओर बॉडी तक पहुंचने के लिए रास्ता बनाते हैं। शाफ्ट सिंकिंग is such a construction in which we try to reach the ore body or the coal seam, okay, by this thing, with the help of this thing. So if we talk about, first of all we will talk about the shape and size of the shaft. Okay, therefore if we talk about the shape, the shape of the shaft is generally circular in shape. Most of the times it is circular only, and in some mines it is in rectangular shape, but most of the time it is circular in shape in shape. अब शाफ्ट के शेप की अगर मैं बात करूं तो शाफ्ट का जो शेप होता है वो ज्यादातर सर्कुलर ही होता है। कभी कभार किसी किसी माइंस में जो है तो इसको जो है तो क्या रखा जाता है, आपका जनरली जो है तो ज्यादातर रेक्टेंगुलर कभी कभार रखा जाता है, बट ज्यादातर आपको सर्कुलर शेप में ही शाफ्ट देखने को मिलता है। अब अगर मैं सर्कुलर शेप के शाफ्ट की बात करूं, व्हाई द सर्कुलर शेप्ड शाफ्ट इज बीइंग कंस्ट्रक्टेड? The reason for constructing a circular shaped shaft is that a circular shape can resist side pressure. It can resist side pressure. As you can see over here, if this is a circular shaft, this is the top view. Okay, and this is the front view. Okay, now if this is your surface, okay, you can stand over here, now this circular shaft, there will be a pressure from the sides over this circular shaft, over the entire length of this circular shaft. So this circular shaft will have to resist pressure from the sides which are occurring on it. If we see in the top view, the side pressures which are occurring on it are like this. Okay, this pressure, side pressure, will be like this if we see the top view. Now if there is a rectangular shaft, then what will happen? What is the reason why we don't use to make a rectangular shaft? The reason for not making a rectangular shaft is that if the side pressure comes on it, then in that case they will bulge out. The sides of the shaft will bulge out like this. There will be a deformation. रेक्टेंगुलर शाफ्ट बनाने का कारण क्या नहीं है, क्यों, कारण क्या है भाई साहब नहीं बनाना है रेक्टेंगुलर शाफ्ट? कारण तो यही है कि भाई साहब इसमें डिफॉर्मेशन हो जाता है, ये बल्ज आउट हो जाता है। While on the other hand, in a circular shaft there is no such cases can be seen, and because there will be compression. If the side pressure comes, then in that case there will be compression from both the sides, and it can resist the side pressure much better than the rectangular shaft. That is the reason why such shafts are not made, rectangular shafts are not made. Okay, this is the reason. Suppose that, and if you want to feel this thing a much more broader way, then I can give you the example. Suppose that there is a river. This is the top view. Okay, top view of the river, you are watching it from the top. Okay, now in this river, if we used to make a dam like this, okay, if we used to make a dam like this, then in that case, what will happen? The pressure, water pressure will come over it, and due to that pressure, it will get deformed. If there is high pressure, it will get deformed to into like this. Okay, and after some time, there will the cracks will develop on it, and this will break. But if we follow the arc method, what is arc method? Like, make the shaft like this, dam like this. Now if the water pressure comes on it, there will be a compression. Okay, the stress that will generate over here, it will be compression, and due to that stress, it may get straight. It may get straight, but it will resist much more better than this type of dam, that is dam number 1. Dam number 2 will resist much more better than dam number 1. This is called the arc method. Arc method. Okay, so these are the things which you have to remember. And the most important thing is that the shaft sinking, circular shaft sinking, is easy to sink. It is very easy to sink. ये इसको sinking करना भी बहुत ज़्यादा आसान होता है. And along with that, it provides less friction to the air, ventilating air, as compared to that of the rectangular shaft. Okay, so there is very less friction to the ventilating air. Along with that, if we talk about the dia of the shaft, the dia of the shaft is approximately 4.2 meter to 6.7 meter. For drum winding, if you want to do the shaft sinking, then in that case drum winding is used. Just remember this thing. In shaft sinking, only drum winding is used. Friction winding is not used in shaft sinking. Friction winding can be used in deep shafts, but after shaft sinking. After shaft sinking, only friction windings can be used. Otherwise, you have to use the during shaft sinking, you have to use the drum winding in arrangement. Okay, so remember this thing. ठीक है, अब आपको ध्यान में ये रखना है कि आपका जो शाफ्ट का डाया होता है वो जनरली 4.2 से लेके 6.7 मीटर के आसपास होता है, और शाफ्ट सिंक करना भी आसान है सर्कुलर के केस में. इसी के साथ ही आपका जो इसका डाया होता है शाफ्ट का 4.2 मीटर से लेके 6.7 मीटर होता है, और जो वेंटिलेटिंग एयर होती है, जो हवा अंदर जाती है, वो इजिली इस शाफ्ट में हवा अंदर जा सकती है, ठीक ना. जिसके कारण मतलब कि फ्रिक्शन बहुत कम होता है. फ्रिक्शन मतलब द force that resist the air from moving forward. Okay, एक ऐसा फोर्स जो कि हवा को आगे बढ़ने से रोकता है, उसे फ्रिक्शन बोल सकते हैं आप. ठीक है, उसके बाद अगर दूसरी चीज ये याद रखना है कि जब भी शाफ्ट सिंकिंग किया जाएगा, उस केस में ड्रम वाइंडिंग ही की अरेंजमेंट किया जाता है, फ्रिक्शन वाइंडिंग अरेंजमेंट नहीं किया जाता है. मान लीजिए आपका डीप शाफ्ट है, तो उस केस में आप ड्रम वाइंडिंग से पहले शाफ्ट बनाएंगे, शाफ्ट सिंकिंग करेंगे, उसके बाद आप फ्रिक्शन वाइंडिंग का इस्तेमाल कर सकते हैं. अब शाफ्ट कहां बनाना है भाई साहब? वेयर वी शुड मेक अवर शाफ्ट, हाउ यू विल कम टू नो दिस थिंग. आप शाफ्ट कहां बनाएंगे ये आपको कैसे पता चलेगा? फॉर नोइंग दिस वी यूज टू ड्रिल द पायलट होल्स. ठीक है, हम पायलट होल्स ड्रिल करते हैं. with the help of the pilot holes we used to get the course, and with the help of that course we used to come to know what is the is it a water bearing strata or not, is there any type of fault or geological disturbances are there or not. On that basis, what type of rock is there, what type of strata is there, or is there any type of you can say soft rock or soft soil, or if we have a hard strata. In such in general informations can be gained with the help of the pilot holes, with the help of the cores collected from the pilot holes. Okay, this will help you out for the site selection of the shaft. ठीक है, अब शाफ्ट का साइड सिलेक्शन करने के लिए हम क्या करते हैं? पायलट होल्स ड्रिल करते हैं। पायलट होल्स ड्रिल करने का फायदा ये होता है कि हमें ये पता चल जाता है कि हमारा स्ट्राटा कैसा है, हमारे स्ट्राटा में रॉक है कि नहीं है, कि या फिर मिट्टी वगैरह है, किस प्रकार से हमारा स्ट्राटा वाटर बेयरिंग स्ट्राटा है या फिर नहीं है, इसकी भी जानकारी मिल जाती है। तो ये सारी थोड़ी थोड़ी फॉल्ट है कि नहीं है, जोलॉजिकल डिस्टर्बेंसेस है कि नहीं, तो ये सारी छोटी छोटी चीजों के बारे में आपको जानकारी कौन देगा? पायलट होल्स। ठीक है, चलो ठीक है, यहां तक तो सर जी समझ में आ गया, बड़ा अच्छा लग रहा है ना। आज बहुत बड़ा दिन है जैसा कि आप सभी जानते हैं, है ना। अब आप बताइए आज बड़ा दिन क्यों है? चलिए, अब पायलट होल्स की जब बात ही उठी है तो देख लेते हैं पायलट होल्स क्या है। अब पायलट होल्स क्या है? तो पायलट होल्स डज नॉट डिपिक्ट द सेंटर ऑफ द शाफ्ट बट इट लाइज विद इन अ रेडियस ऑफ 50 मीटर ऑफ द शाफ्ट। पायलट होल्स कभी भी ये पायलट होल्स को आप ये सोच के नहीं चलेंगे कि मैंने यहाँ पायलट होल ड्रिल किया अब ये मेरे शाफ्ट का सेंटर होगा। नो, ओके, you should not think that if you have drilled a pilot hole then that pilot hole will be at the center of the shaft. No, it's not like that. The the other case can be, if you think, can be that the pilot holes will lie within a radius of 50 meter of the shaft, but they will not be the pilot holes will not be the center of the shaft. You should have to remember this thing. Okay, so आपका पायलट होल शाफ्ट के 50 मीटर के रेडियस में होता है जनरली, बट वो शाफ्ट का सेंटर नहीं माना जा सकता है। अब पायलट होल्स हमें क्या क्या डिटेल्स देता है? तो हमें क्या क्या डिटेल्स देता है? सबसे पहले तो कंफर्मेशन ऑफ द शाफ्ट साइड, इट गिव्स अबाउट द डिटेल्स अबाउट द कंफर्मेशन ऑफ द शाफ्ट साइड। ऑन द अदर हैंड, selection of the water control methods. If you have a water bearing strata and then also you have to construct the shaft, then in that case it will give you the method. On that basis or on the basis of the study of the core, you can decide what type of water control methods should I apply in our mines or during the shaft sinking or the whole life of the shaft sinking, so that they should not get collapsed. After that, estimation of the sinking time and the cost. You will also get the estimation of the cost, what amount of money you have to invest, and the time, what quantity of time you have to invest, because time is money. Just remember this thing, time is money. Okay, now design of shaft and permanent lining. You can get the details. So if you have the details of the strata, what type of strata we have, what are the geological disturbances are there, then on that basis you will design your shaft. You will decide the permanent lining which has to be provided on the shaft, so that your shaft should remain to the whole till the whole life of the mines. Remember this thing. सो आपका पायलट होल्स क्या क्या डिटेल्स देता है? पायलट होल्स तो भाई ये सब बता देता है कि आपका शाफ्ट, सबसे जरूरी चीज क्या है, शाफ्ट कहां बनाना है, इसकी जानकारी दे दिया। उसके साथ ही अगर आपको यह पता है कि मेरा वाटर बेयरिंग स्ट्राटा है, तो उस केस में वाटर को कंट्रोल करने के लिए मुझे क्या क्या मेथड्स अपनाने हैं, ये तो जानकारी मिल ही जाएगी। उसके साथ ही आपको यह पता चल जाएगा कि भाई मनी भाई कितना लगेगा, है ना, क्योंकि पूरी दुनिया तो मनी भाई के पीछे भाग रही है, तो भाई उसमें कितना टाइम लगेगा, कितना पैसा लगेगा, तो उसके बेसिस पे आप जो तो एस्टिमेट कर बना सकते हैं अपना। नहीं तो पता चला कि साला पैसे खत्म हो गया बीच में, है ना, शाफ्ट बना रहे पैसे खत्म हो गया, अब क्या करें, बीच में तो काम रोक नहीं सकते हैं, है ना। दूसरा, आपका शाफ्ट का डिजाइन भी आप डिसाइड करोगे और उसके साथ ही परमानेंट लाइनिंग भी डिसाइड करोगे कि आखिर कौन सी परमानेंट लाइनिंग मुझे प्रोवाइड करानी है। अगर मैं बात करूं रेक्टेंगुलर शाफ्ट की, ठीक है, अगर मैं बात करूं रेक्टेंगुलर शाफ्ट की, तो आपका जो रेक्टेंगुलर शाफ्ट होता है वो कहां पर बना हुआ है? तो इंडिया में आपका मोचिया मोगरे माइंस, मोचिया मोगरे माइंस, ये एक एग्जांपल है जो कि आपका ज्वार जोवार राजस्थान। A rectangular shaft has been constructed in the Mochia Mogre mines in Jwar, Rajasthan. Okay, SCL, that is Hindustan Copper Limited. It has a rectangular shaft of dimension 5.2 meter into 2.8 meter, and the depth of that shaft is 321 meters. Okay, having a 30 centimeter thick concrete line. Okay, so if we talk about the cost, now if we are talking about the cost, then what is the cost of shaft sinking? Earlier, the cost of shaft sinking, if we talk about the early data, then on that basis, the cost of shaft sinking was approximately 50,000 to 75,000 per meter. Okay, and it includes all the things like sinking, lining with concrete, headgear, winding engine, and the concrete. Okay, all these things are included in this 50,000 to 75,000. Okay, clear? Any type of doubt? अरे बोल तो रहा हूँ भाई हिंदी में. हिंदी में बोला तो हिंदी में देखो. इतनी प्यारी हिंदी बोल लेता हो यार, वो भी तुम्हारे जैसी है. चल, अब भाई चलो ठीक है, जान गए साहब कि शाफ्ट कैसा बनाना है. शाफ्ट बनाने के लिए सबसे पहले मुझे क्या करना पड़ेगा, कितना पैसा लगेगा वो जानने के लिए मुझे क्या करना पड़ेगा, शाफ्ट कहाँ बनाना है ये जानने के लिए भी मुझे पायलट होल्स ड्रिल करने हैं. लेकिन सर ये बताइए कि व्यवस्थाएं क्या क्या करें, क्या क्या अरेंजमेंट करें, मुझे शाफ्ट बनवाना है. तो शाफ्ट बनवाने के लिए हमें जो सबसे पहली व्यवस्था करनी है वो क्या कहलाएगा, सरफेस प्लांट एंड इक्विपमेंट्स. ठीक है, आपका सरफेस पर आप क्या प्लांट बनाएंगे, क्या इक्विपमेंट्स होंगे, वो सारी डिटेल्स हम यहाँ पर देखते हैं. तो सबसे पहले तो एक इंजन सेट करो, चाहे वो स्टीम बॉयलर वाला हो या डीजल इंजन हो या इलेक्ट्रिकल पंप हो, जिससे की मदद से आप क्या कर सके, वाइंडिंग इंजन, अपना पंप वगैरह सब कुछ चला सके, है ना. व्यवस्था तो बनाओगे ना भाई, चाहे डीजल डीजल इंजन रख लो, चाहे स्टीम बॉयलर रख लो, या इलेक्ट्रिसिटी का इस्तेमाल करो, इट डजेंट मैटर. जो सस्ता पड़े, जो अवेलेबल है इजी वे में, उसका इस्तेमाल करिए. ओके, first of all you have to arrange for the steam boilers, diesel engine or the electric pump for winding engine. Okay, and for the pump to run this all this thing, winding engine and the pump, you need some sort of energy. That power supply or will be from the steam boilers, diesel engine or the electricity. Okay, the next thing which you have to arrange is the winding engine having locked coil ropes. What is the use of the locked coil ropes? Locked coil ropes are basically non-spinning type of ropes. Okay, you have to remember this thing. Locked coil ropes are basically are of non-spinning type ropes. Basically, because why we use the non-spinning type ropes? The reason for using locked coil ropes, or I should say that non-spinning type ropes is that in the case of shaft sinking, the bucket is hung freely. Okay, the bucket is hung freely. suppose that suppose that if I have this, are you able to see? Suppose that this is a bucket. Okay, if I will use to sink it, then in that case it will rotate. Okay, it will rotate like this. Okay, it will rotate like this. So this is called spinning, and to stop this kind of spinning, what we have to do, what we have to do we have to just use the locked coil ropes. Locked coil ropes will stop it from spinning, and this will go down directly. Because why such kind of such sort of things occur in the shaft sinking, during shaft sinking only? This can occur after the shaft sinking also. Some sort of the this kind of दिक्कत दिक्कत कहाँ आ रही है? अब इस टाइप की दिक्कत आखिर यहाँ पर क्यों अकर होती है, ठीक है, तो शब्द नहीं याद आ रहा यार, पता है इस टाइप की दिक्कत यहाँ पर क्यों आ रही है, क्योंकि आपका सबसे बड़ी दिक्कत ये है कि आपका जो शाफ्ट सिंकिंग होता है, ड्यूरिंग शाफ्ट सिंकिंग वी डू नॉट यूज द गाइड रोप्स, बट आफ्टर शाफ्ट सिंकिंग वी कैन यूज द गाइड रोप्स. That's why locked coil ropes or the non-spinning type ropes are used over here. So there is a steel headgear. Okay, this can be temporary. The steel headgear can be of temporary basis. On the other hand, we will use the double drum winch for walling scaffold. Okay, there is a winch like during while fishing, as you use the such sort of things, that is in fishing, as you maybe you have seen in the movies, that in fishing winch arrangement is there in the fishing rod. Okay, with the help of that winch you can just release the rope or you can wind the rope. So in this manner, similarly, winch double drum winch is placed in the shaft sinking during shaft sinking, so that you can handle the walling scaffold, lighting cables, short firing cables, pump suspension ropes, and the pump cables. All these things are being controlled by the डबल ड्रम विंच. ठीक है, अब यहाँ पर डबल ड्रम विंच प्रोवाइड किया जाता है. ठीक है, डबल ड्रम विंच प्रोवाइड किया जाता है, जो कि आपका वॉलिंग स्कैफोल्ड को सस्पेंड करने के लिए होता है. जो लाइटिंग केबल्स होती है उसको सस्पेंड कर सकते हो, लटका सकते हो. शॉर्ट फायरिंग केबल्स, पंप सस्पेंशन रोप्स, पंप केबल्स, सभी चीजों को सस्पेंड करने के लिए, लटकाने के लिए डबल ड्रम विंच का इस्तेमाल किया जाता है. ठीक है, उसके बाद आपका एयर कंप्रेसर लगा होता है, जिसकी मदद से आप जैक हैमर ड्रिल्स और अदर इक्विपमेंट्स को ऑपरेट कर सकते हैं. देयर इज अ एयर कंप्रेसर विद द हेल्प ऑफ व्हिच यू कैन ऑपरेट द जैक हैमर ड्रिल्स एंड द other equipments. And there is a fan which has a capacity of 300 cubic meters per minute. Okay, it is placed near in the shaft. Okay, the fan is placed in the shaft having the capacity of 300 cubic meters per minute capacity. Okay, तो यहाँ पे एक फैन भी लगा दो, पंखा लगा दिए. As you can see over here, this is a shaft in which rider is placed over here. This is your rider. This is your rider. Okay, this is your bucket. Okay, this is your upper folding door. Okay, this is your lower folding door. After that you have the air tubes running down the shaft. Okay, for providing air over here in this portion. From here air comes out of the shaft. Okay, now there is a walling scaffold. This is your walling scaffold. Workers usually stand on this walling scaffold for providing the permanent lining. The other use of this walling scaffold is that it will help you out from if anything will drop from the top of the shaft. If anything will drop from the top of the shaft, then it will not reach to the man who is standing at the bottom of the shaft. If by mistake, okay, no one will try to hurt anyone intentionally. If by mistake something drops, then in that case it will provide safety. Okay, therefore it is like a safety equipment over here. So now इज इट क्लियर टू एवरीवन? हाँ, यहाँ पे क्या क्या है, राइडर है. राइडर का काम क्या होता है, शाफ्ट में जब बकेट जाता है, what is the use of the rider? If the bucket goes down the shaft, then in that case it will stop the bucket from swinging. You can stop the spinning of the ropes or spinning of the bucket with the help by using the locked coil ropes, but swinging cannot be controlled by the locked coil ropes. Just remember this thing. Swinging of the bucket cannot be controlled by the locked coil ropes. What is the difference between the swinging and the spinning? Okay, swinging and spinning. I will show you. Maybe if it does not fall, then it will be good. Does not fall. This is called spinning. Okay. And this is called swinging. This is swinging and this is spinning. Okay. This is the basic difference between between swinging and spinning, and rider over here will help you out to prevent the swinging of the buckets. Okay, so this is your rider, and after that you have the upper folding doors. Two doors you have, that is the upper folding door and the lower folding door. There is an air tube with the help of which you are able to provide the air at the bottom of the shaft. After that you have a walling scaffold. Okay, this is your walling scaffold over which your workers will stand and provide the permanent lining. After that है ना, आपका जो जिसके ऊपर आपके वर्कर्स जो है तो खड़े होकर क्या प्रोवाइड करेंगे, परमानेंट लाइनिंग वगैरह प्रोवाइड करेंगे. ठीक है, अब सबसे बॉटम में होता है, व्हाट इज एट द बॉटम, देयर इज अ टेम्पररी लाइनिंग प्रोवाइडेड एट द बॉटम which will be removed after the depth of the shaft gets increased. Then after that you will provide the temporary lining. So let me know, just tell me if you are active in these classes, okay, and if I have studied the legislation, then tell me what must be the distance between shaft bottom and walling scaffold. What must be the distance between, wait a minute, I should write the question according to the CMR 2017, and what must be the distance between temporary permanent lining and bottom of the shaft. You have to answer these two things. Okay, now शाफ्ट बॉटम और वॉलिंग स्कैफोल्ड और परमानेंट लाइनिंग, इनके बीच का जो डिस्टेंस है शाफ्ट बॉटम से कितना होता है, ये आपको बताना है. चलिए सीएमआर 2017 के अनुसार बताइए कितना होता है. ठीक है, और गाइड रोप्स कब यूज कर सकते हैं. ओके, वेरी गुड. गाइड रोप्स का इस्तेमाल कब कर सकते हैं शाफ्ट सिंकिंग में. ओके, एज यू कैन सी ओवर हियर, this is your walling curve provided here, and this walling curves are joined with the help of wedges. Okay, wedges are placed in between them, and by bolting them you can join two walling curves. Okay, आपके यहाँ सामने क्या है, आयरन के वॉलिंग कर्व्स हैं जिनको अपन वेजेस वगैरह लगा के टाइट करते हैं, और बोल्ट्स की मदद से इसके जॉइंट्स को हम जो है तो एक दूसरे से जोड़ देते हैं. ठीक है, वॉलिंग कर्व का इस्तेमाल क्या होता है, व्हाट इज द यूज ऑफ द वॉलिंग कर्व. बेसिकली if you want to do the shaft sinking for providing the temporary lining or the permanent lining, you have to place a circular ring all over the corner sides of the shaft. This circular rings you can place your wooden planks, which will help you out for the providing the permanent lining or the temporary lining. Both can be done with the help of this rings. Okay, and along with that all the equipments can be hung through it. All the this will help you out to control the shaft from being collapsing. Okay, from being collapsing. Okay, the next thing, the next arrangement you have to you must have is that the generator. Okay, there must be a generator. It can be diesel generator or the steam engine, and it will be used for the lighting purpose. ठीक है, आपके पास जो दूसरी चीज होनी चाहिए वो क्या होना चाहिए, जनरेटर होना चाहिए, जिसका वो कि डीजल भी हो सकता है या फिर आपका स्टीम इंजन वाला जनरेटर भी हो सकता है, ठीक है। उसके बाद आपका बोलता है कि इसमें आपका किस लिए इस्तेमाल किया जाएगा, लाइटिंग के लिए इसका इस्तेमाल कर ले। जनरेटर लगा दिए भाई साहब, जनरेटर जैसे ही आपका लग जाए तो फिर उसके बाद आप क्या इस्तेमाल करेंगे, फोल्डिंग डोर्स का इस्तेमाल करेंगे। फोल्डिंग डोर्स विल हेल्प यू आउट टू कवर द शाफ्ट टॉप। ओके, उसके बाद आप क्या करेंगे, शाफ्ट सेंटरिंग अरेंजमेंट करेंगे। व्हाई वी विल नीड द शाफ्ट सेंटरिंग अरेंजमेंट, वी कैन नॉट मेक द शाफ्ट लाइक दिस in this their shape na, we have to make a vertical shaft, okay, so that so in that case you have to make some arrangements for the shaft centering with the from the center of the shaft you can maintain your shaft dia, okay, from the center of the shaft you can maintain your shaft dia and your shaft will go vertically downwards direction, okay. So this arrangement, centering shaft centering arrangement is done over here. After that, signaling and signaling arrangement is done at the pit top and the pit bottom for providing signals in the winding engine room, ठीक है। इसी के साथ ही आपका जो है तो क्या प्रोवाइड किया जाता है, सिग्नलिंग अरेंजमेंट प्रोवाइड किया जाता है शाफ्ट के पिट टॉप पे और पिट बॉटम पे, ताकि वाइंडिंग इंजन रूम में क्या करो, ट्रिंग ट्रिंग करके घंटी बजा सको। उसी के साथ ही आपका शाफ्ट सेंटरिंग अरेंजमेंट, शाफ्ट को टेढ़ा मेढ़ा तो बना नहीं सकते हो, कुरकुरे तो है नहीं, अगर कुरकुरे नहीं है तो इसका मतलब हमें इसको सीधा बनाना पड़ेगा, और सीधा बनाना पड़ेगा इसका मतलब क्या है भाई साहब, इसके लिए आपको शाफ्ट सेंटरिंग अरेंजमेंट करना पड़ेगा, ठीक है। उसके साथ ही और क्या क्या जरूरत है भाई साहब, और क्या क्या लोगे, शूट्स, शूट्स पढ़ना है इसको, ठीक है। उसके बाद बकेट्स, टिपिंग टब्स, ठीक है, इसके जिसमें कि ट्रैम लाइन का इस्तेमाल हो, ठीक है, ताकि क्या कर सके, डेब्रिस को रिमूव कर सके, ओके। डेब्रिस मतलब for removing the debris that is the waste material of the during shaft sinking you are getting, that you are getting, they can be removed with the help of chutes, buckets or the dipping tubs with a tram line, okay. There must be a workshop if any of the equipment gets damaged or gets has to be maintained, and maintenance of any of the equipment has to be done, then in that case workshop must be established over there. You must have a lamp room, first aid room, magazine stores and the office, etc. All these things has to be established on the surface. ये सारी चीजें आपको surface पर establish करना पड़ेगा, जरूरी है। और इस तरीके से हमने सारी व्यवस्थाएं कर ली। in this manner we have done all the arrangements for the shaft sinking. Now we have to do the shaft sinking. सबसे पहले तो हमने क्या किया, first of all we have seen that what was be the shape and size of the shaft sinking. The second question was where we have to make our shaft, the site selection of the shaft. The third thing, what arrangements I have to do for the shaft sinking, okay. All the answers of all these questions are given. Now we have to find out, we have to do the shaft sinking, okay. अब हमें शाफ्ट सिंकिंग करना है, हमें यह पता चल गया कि शाफ्ट कैसा होता है, कैसा आपका जो है तो कहां पर बनाना है ये भी पता चल गया है, उसके लिए क्या व्यवस्थाएं करनी ये भी पता चल गया। अब शाफ्ट सिंकिंग करेंगे कैसे, तो आपका शाफ्ट सिंकिंग करने का प्रोसीजर यहां पर अब हम देखेंगे, ठीक है, ओके। उसके पहले आपको एक चीज ध्यान में रखनी है कि शाफ्ट सेंटरिंग अरेंजमेंट में, बिफोर दैट यू हैव टू रिमेंबर दैट इन द शाफ्ट सेंटरिंग अरेंजमेंट, फॉर द शाफ्ट सेंटरिंग अरेंजमेंट और इन द शाफ्ट सेंटरिंग अरेंजमेंट, shaft center is marked by the concrete pillar in the concrete pillars. Center line is marked on the plates in each pillar, okay. There are concrete pillars are made on which the center of the shaft is being marked, and there is a center line which is marked on a plate, and that plate is placed on the on this concrete pillars, okay. Now if we talk about the shaft sinking strata, that what kind of strata we will get if we start the shaft sinking, अगर मैंने shaft sinking start किया तो मुझे कैसा strata मिलेगा, कैसा strata मिलेगा। फर्स्ट ऑफ ऑल वी विल गेट द सबसॉइल और द एल्यूवियम, पहले हमें क्या मिलेगा, सबसॉइल मिलेगा, उसके बाद एल्यूवियम मिलेगा या फिर एल्यूवियम मिलेगा। दूसरा हमें क्या मिलेगा, हार्ड रॉक्स मिलेंगे, ठीक है, वी विल गेट द हार्ड रॉक्स दैट विल बी प्रेजेंट बिलो द एल्यूवियम और द अबव मिनरल बेड सैंडस्टोन shale thin coal seams, okay. After that we will get the coal seam or the mineral bed, okay. All these are the strata of the shaft sinking, which you have to which you will encounter during shaft sinking. Okay. Now, if we talk about the perimeter of the shaft, what must be the perimeter of the shaft? What do you mean by perimeter? That means perimeter of the shaft means circumference of the shaft. शाफ्ट का पेरीमीटर क्या कहलाता है? सरकमफ्रेंस कहलाता है, ठीक है, क्योंकि वो सर्कुलर इन शेप होता है, ठीक है, रेडियस है, तो इसका मतलब इसमें पेरीमीटर नहीं होता, सरकमफ्रेंस होता है, बट हम जनरली पेरीमीटर भी बोल सकते हैं, उसमें कोई इशू नहीं है, ठीक है। अब पेरीमीटर को हिंदी में क्या बोलते हैं यार, कोई बता सकता है? सॉरी, सरकमफ्रेंस को हिंदी में क्या कहते हैं? मुझे आइडिया नहीं है क्या बोलते हैं हिंदी में, याद नहीं है, मतलब पता है बट याद नहीं आ रहा। बताइए, तब तक हम पानी पी की व्यवस्था कर लें अपनी। चलो, परिधि, आई थिंक, सॉरी। Now, if we talk about the radius perimeter of the shaft, if we talk about the perimeter of the shaft, so there are pegs placed over the shaft in the sides for marking. Okay, along with that radius, if we talk about the radius of the shaft, the radius of the shaft is equals to 3 finished radius plus thickness of the lining plus clearance of 230 to 300 mm. This will be your radius of the shaft. There will be a collar or shaft collar, which will be the starting point of the vertical shaft at the surface. After that, in subsoil or the alluvium, which is up to the depth of the 3 meter to 20 meter, excavation is done by with the help of the chisel and hammer or the cutting picks. Blasting is not done up to 3 meter to 20 meter if there is the presence of alluvium or the subsoil. After the alluvium or the subsoil is over, you can do the drilling and blasting. Okay. After that, you have to remember that excavator material is hoisted with the help of the buckets and the rope which is used for raising and lowering of the buckets. That rope is called the Manila rope, and the name of that rope is the Manila rope, or we can use in the for that purpose we can use the cranes also. Okay. Now, crane can also be used up to the 30-meter depth. Okay, at the time of the sinking shaft, the sides are kept vertical and circular. Okay, and the radius rods can also be used to hang the plumb bob wire for measuring the radius at the center of the shaft from the surface. Okay, from the surface you can measure the radius of the shaft by hanging the plumb bob wires. Okay, at the center of the shaft you can in that manner you can measure the radius of the शाफ्ट। अब देखिए यहाँ पे पेग्स की मदद से आप मार्किंग कर सकते हैं। अगर आपको शाफ्ट का जो पेरीमीटर है या जो एक्सकवेशन आप कर रहे हो, जो गड्ढा आप खोद रहे हो, ठीक है, आप अपने लिए जो गड्ढा खोद रहे हो, दूसरे के लिए भी नहीं, अपने लिए ही गड्ढा खोद रहे हो, तो जब ऐसा काम आप करोगे तो इन दैट केस के आपका जो मार्किंग किया जाएगा रेडियस, पेरीमीटर वगैरह, उसके लिए आप पैक्सिस का इस्तेमाल करेंगे। उसके बाद जो शाफ्ट का कॉलर है वो तो आपका टॉप हो गया, ठीक है। फिर उसके बाद सबसॉइल या फिर एल्यूवियम में लगभग 3 मीटर से 20 मीटर की डेप्थ तक आप क्या करेंगे? एक्सकवेशन करेंगे, ठीक है। इसके लिए आप चिजल, हैमर या फिर कटिंग पिक्स का इस्तेमाल कर सकते हैं। ब्लास्टिंग नहीं किया जाता है 20 मीटर की गहराई तक, जब तक एल्यूवियम सॉइल मिलता है या फिर सॉफ्ट सॉइल मिलता है, ठीक है। उसके बाद जो एक्सकवेटेड मटेरियल है उसको हॉइस्ट करने के लिए आप बकेट्स का इस्तेमाल करेंगे, जिसमें कि आपका मनीला रोप का इस्तेमाल होता है इस पर्पस के लिए। क्रेन का इस्तेमाल भी कर सकते हैं अगर 30 मीटर की गहराई तक काम करना है तो, ठीक है। शाफ्ट सिंकिंग के समय शाफ्ट साइड्स को वर्टिकल और सर्कुलर रखा जाता है। रेडियस रॉड्स का भी इस्तेमाल कर सकते हैं शाफ्ट के रेडियस को पता करने के लिए, जिसमें के लिए आप क्या कर सकते हैं? रेडियस रॉड से प्लम्ब ऑफ वायर को हैंग कर सकते हैं शाफ्ट के सेंटर पर। तो ये कुछ तरीके हैं जिनकी मदद से आप यह काम कर सकते हैं। चलिए, अगर शाफ्ट कॉलर देखना है तो चलो शाफ्ट कॉलर दिखाते हैं यार तुमको।
Pressure, combined with layers of hard and soft material. Deep shaft footprints.
In this manner, cutting picks are used over here.
2 meters in depth, and a support concrete ring beam is with limited construction footprints. The initial section is excavated 1 to 2 meters.
Okay, as you can see over here, there is an initial excavation up to 2 meters. After that, a concrete ring is placed over here, and after that, you can see over here, shaft collar is made. This is called the shaft collar. Okay.
Has an integrated steel edge, which acts as a cutting knife during the shaft sinking.
Now,
jacks are installed on the support concrete.
Just watch over here.
It has an integrated steel edge, which acts as a material, which can affect a wide area in inner city areas with limited.
This is the cutting pick.
And absorbs the forces from the shaft.
Just watch carefully.
The first.
Okay, just watch carefully. While making this shaft collar, the bottom ring has a cutting pick. Okay, it has a cutting edge, because as the shaft sinking progresses, then in that case, this cutting edges will help to move the whole shaft in the downward direction, so that you can just place the each ring over each other. Then in this manner, you don't have to worry about the walling or the permanent lining. You can just you don't have to place the walling scaffold. You just have to place the rings over one another, on one another. Okay, above one another. ओके, अब देखिए यहाँ पे क्या है कि जैसा कि आप देख पा रहे हैं, ये आपका रिंग्स डाली जा रही हैं. इन रिंग्स में क्या होता है कि आपका जैसे जैसे शाफ्ट सिंकिंग होता है, तो ये रिंग्स में कटिंग एजेस होते हैं. जो सबसे बॉटम वाली रिंग होती है, उसमें कटिंग एजेस होते हैं. अब ये कटिंग एजेस का फायदा ये होता है कि जैसे जैसे मेरी शाफ्ट सिंकिंग होती जाती है, तो ये कटिंग एजेस और नीचे जमीन में धंसता चला जाता है, उसके साथ साथ आगे बढ़ता जाता है. अब मुझे इसके लिए परमानेंट लाइनिंग करने के लिए ज्यादा दिक्कत नहीं होती है. अब इसमें मुझे क्या करना है, बस उसके टॉप पे रिंग्स वगैरह रखते चले जाने हैं, मेरा काम होता चलता चला जाएगा. ठीक है, तो ये चीज आपका बेनिफिशियल होता है.
The bottom segment ring has an integrated steel edge.
As you can integrated steel edge. Okay, this is the shaft collar, and now we are making arrangements for the cutting picks, which will help to excavate it.
The shaft is now held in position by this compact strand jack system. Preparation for the machine installation starts by using a dummy frame to position the brackets for the machine arm.
This is the method in which you don't have to the drilling and blasting. You can just use the cutting picks.
The VSM machine is assembled with correct.
This is also called the VSM machine, which is used for the shaft sinking. This is placed over here. Now, as you can see in the VSM machine, there is a cutting head that will basically cut the bottom of the shaft. Like this, it is placed in the shaft.
The shaft sinking equipment can now be installed. The 3 winches are used to lift and lower the machine.
These are the winches which will lift all over the machine. As you can see over here, this is a winch.
The energy and supply lines provide
Okay.
the machine with all necessary power, fluids.
This is the VSM machine, which is used for shaft sinking.
This is an example of a complete site setup.
As you can see, this is the side setup of the shaft sinking.
Operations are powered and controlled from the container on the surface. Stored data, together with the position of the cutter boom, is shown on a graphic display, giving the operator full control of the excavation and sinking process. The cutter boom can either be controlled manually by the operator or set in automatic mode for cutting the set profile in the required section. The shaft is kept full of water during sinking to balance the level of the groundwater table in the surrounding geology. In addition, the water itself is used as the transport medium for the excavated ground. Various depths of the groundwater level can be handled. The flexibility of its telescopic arm rotation and slewing movements allows the cutter boom to work in shafts with inner diameters from 4.5 meters and outer diameter up to 18 meters in water depths up to 80 meters.
Telescopic, it has a telescopic extension of up to 1 meter. After that, you have to lower the whole system, whole arrangement. Okay.
Cutting arm moves radially from the
This is the
center to
cutting
the
arm,
outside of the
and
shaft.
this is the cutting head.
In soft soil, cutting edge on the shaft
It
is
will
used
cut
to
the
bring
soft
the
soil
excavation
very
deep
easily.
into the ground. The cutting speed and the movement of the boom can be varied to achieve the best excavation rate. When it's necessary to excavate under the cutting edge, such as in hard soil, the machine
As you can see over here, the cutting edge moves downwards.
to extend the reach of the boom. Where hard soil is a shaft sinking and construction of the next rig suit the shaft's purpose. Concrete segments with rubber sealing.
As you can see over here, the next segment is placed over here. Okay. In this manner, whole shaft sinking procedure is done.
Can take place continuous depending on the diameter, geology, and working hours. Prepared with a built-in launch eye to exactly suit the tunneling equipment. An automatic bentonite lubrication system reduces friction between the shaft exterior and the surrounding ground during shaft sinking. The total number of nozzles is designed to suit the soil conditions. When the shaft reaches the final depth, the VSM machine is removed and the concrete base block is cast.
What is the full form of VSM machine? Vertical shaft sinking machine. Okay. Vertical shaft sinking machine. This is called the VSM machine. Is it clear to everyone? Next, temporary lining. Now, there are two types of lining. That is the temporary lining and the permanent lining. Okay. Now, there are two types of lining. First of all, we will do the temporary lining. After that, we will do the permanent lining. Permanent lining is such that it will remain till the whole life of the mines, and the temporary lining is such that it will remain till you construct the permanent lining, or it is safe to construct the permanent lining. Till that time, you have to rely on the temporary lining. अब देखिए दो टाइप की लाइनिंग हो गई, एक टेम्पररी एक परमानेंट. टेम्पररी लाइनिंग जो होती है सॉरी, परमानेंट लाइनिंग जो होती है वो आपका शाफ्ट जब तक रहता है, जब तक है जान तब तक वो रहेगा. ठीक है, क्योंकि वही आपके शाफ्ट की या आपके माइंस की लाइफ है. ठीक है, लाइफ लाइन वही होती है, वो पूरे जिंदगी वहीं पे रहना है जब तक माइन से तब तक. ठीक है, लेकिन जो टेम्पररी लाइनिंग होती है उसकी जो टाइम पीरियड होता है कि कब तक उसे लगा के रखना है, तो जब तक आप एक सेफ डिस्टेंस पर ना पहुंच जाए या फिर जब तक आप परमानेंट लाइनिंग कंस्ट्रक्ट नहीं कर देते तब तक आपका जो है तो टेम्पररी लाइनिंग लगा रहता है. ओके, सो व्हाई डू वी construct the temporary lining? Basically, we used to construct the temporary lining to prevent collapse of the shaft sides. Okay, for that a heavy, what is temporary lining? Basically, temporary lining is a heavy frame wood or steel which is made at the top of the shaft, and the topmost ring of the temporary lining is suspended from the headgear. Okay. Okay, first of all you will make a temporary lining like this. This is like this, something like this. Okay. Okay, in this manner temporary lining is made, and this first ring, this is called the first ring. The first ring of the disc temporary lining is hung into the shaft with the help of the headgear, from the headgear. Okay, तो आपका जो headgear होता है उससे जो first, oh my god, 206, the first ring of the temporary lining is जो होता है उसको जो है तो अपन हेडगियर के से टांग देते हैं, किसमें, शाफ्ट में। ठीक है, शाफ्ट में आ गया। अब चलो आगे क्या करना है, उसके बाद हमें क्या करना है, टेम्परेरी लाइनिंग को जो है तो हम आयरन स्पाइक्स की मदद से भी सस्पेंड कर सकते हैं। व्हाट डू यू मीन बाय आयरन स्पाइक्स? आई विल शो यू द आयरन स्पाइक्स। ओके, वेट अ मिनट। टेम्परेरी लाइनिंग में आपका क्या क्या होता है, सबसे पहले होता है स्केलेटन रिंग, हैंगर्स, planks of salwood and the tightening wedges. Now we will see the temporary lining. Okay, so in tomorrow's lecture I will show you that. Leave it. Let's come to the point. We will consume more time. Okay, as we were talking, there is a temporary lining which consists of the skeleton rings. It consists of the skeleton rings, head hangers, planks of the planks of salwood and the tightening wedges. If we used to understand this thing, first of all we have to know about each and everything. Salwood is basically a type of wooden planks. Okay, लकड़ी का पटरा कह सकते हो। ठीक है, ओके, नाउ स्केलेटन रिंग्स। अब आपका इन टेम्परेरी लाइनिंग व्हाट यू हैव स्केलेटन रिंग्स। स्केलेटन रिंग्स क्या होते हैं, व्हाट डू मीन बाय स्केलेटन रिंग्स? बेसिकली इट इज अ रिंग मेड ऑफ माइल्ड स्टील। इट इज इन द फॉर्म ऑफ सेगमेंट्स ऑफ 3 मीटर ईच। ओके, it is in the shape of the circumference of the shaft and the width is 100 mm, thickness is 25 mm. Okay, it is joined with the help of the fish plates or overlap joints. Assembling is done at the surface. Its assembling is done at the surface. Basically, suppose that you have a steel plate in the shape of in this manner. Okay, the shape of the steel plate is like this. What you have done, you have taken 2 or 3 steel plates like this. Okay, this small steel plates, okay, having a width of 100 mm, having a width of approximately 100 mm, are interconnected, are joined by with the help of the fish plate. Okay, are joined with the help of the fish plate. With the help of the fish plate in this manner, and this ring is kept inside the shaft. Okay, it is kept suspended inside the shaft with the help of the headgear. After suspending it inside the shaft, suppose that this is your shaft. Okay, this is your headgear, and with the help of the headgear, okay, this ring, after making it on the surface, after making it on the surface, this ring is hung in this manner or suspended in this manner with the help of the headgear. Okay, after that a second ring is hung from it. Okay, but this second ring, okay, this is the ring number 1 which is suspended with the help of the headgear, but the second ring, it will be suspended with the help of the first ring by using the hangers are S-shaped. Okay, it is S-shaped. In this manner you can suspend rings one over the other. Okay, for joining the rings you can use the overlap joints as I have shown in the previous slide. Okay, so are you able to understand these things? You have to just imagine, because very few wooden planks. If we talk about the wooden planks, now the length of the wooden planks is 2 meter, width is 215 meter mm. and the thickness is 38 mm. Okay, length of each wooden plank is 2 meter. So if you place a skeleton ring over here, and after that at the bottom, at its bottom there is another skeleton ring, then in that case you have to place in between them a wooden plank. A small piece of wood is placed in between them like this. Okay, in this manner, all around the, in a circular manner, over at the around the sides of the shaft, all around the sides of the shaft in the skeleton ring, wooden planks are placed. Okay, these rings and the planks are tightened by placing the wedges in between them. Okay, and every ring is suspended by the upper ring with the help of the iron hanger. As I have said, the topmost ring is hung suspended with the help of by the headgear, but the bottom rings are suspended with the upper ring with the help of the iron hangers, and the dia of this iron hanger is 25 mm. If we talk about the iron hangers, the shape of the iron hangers is like this. The shape of the iron hanger is like this. It is like this. So this is your, just suppose that this is your ring from the side view. Okay, if you will see in front view, your ring will be like this. But if you will see from the side, okay, then in this manner you will be able to see this hanger. Okay, and the ring is inside this. Okay, inside the hanger like this. After that, the bottom ring will be in this manner over here. This is your complete iron hanger, and the dia of this hanger is 25 mm. So the what will be the interval between two hangers? So the interval between the two hangers is 1.2 meter. Every fourth or fifth ring is supported by the plugs by drilling holes. Okay, plugs, what do you mean by plugs? It is also a piece of wood which is inserted into the sides of the shaft. Okay, so that extra support can be provided to them. As you all know, if we hang, or if we will suspend each and every ring one below the other, or with the help of the above rings, then the weight on the upper ring will be very large, and so, it may get collapsed. So for providing extra support, we used to place the plugs on the sides of the shaft. This will provide extra support. ठीक है, अब अगर मैं रिंग्स को एक लाइन से खड़ा डालते चले जाऊं, ठीक है, अगर मैं रिंग्स को क्या करूं, एक दूसरे के नीचे जो है तो एक दूसरे के हेल्प से सस्पेंड करते चले जाऊं, तो एक समय क्या आएगा कि बहुत ज्यादा वजन हो जाएगा, और बहुत ज्यादा भारी होने के कारण क्या होगा, वो कोलैप्स हो सकता है, वो गिर सकता है। तो इसलिए हम क्या करते हैं, एक्स्ट्रा सपोर्ट प्रोवाइड कराने के लिए, फॉर एक्स्ट्रा सेफ्टी, फॉर द पर्पस ऑफ द एक्स्ट्रा सेफ्टी, वी यूज टू ड्रिल द होल्स इन द, हम जो शाफ्ट के साइड से उसमें होल ड्रिल्स करते हैं और उसमें प्लग्स डाल देते हैं। ठीक है, उसके बाद तो हर चौथे और पांचवें रिंग के बाद ये काम करना है, और फिर अपन क्या करेंगे, फ्रिक्शन प्लैंक जो है तो वहां पर अपनी जगह पर लगा दिया जाता है। ठीक है, अब आपके जस्ट सपोज, अब आपने क्या किया, शाफ्ट सिंकिंग किया। बोलोगे सर हमने तो शाफ्ट सिंकिंग कर दिया, लेकिन क्या ये सही चीज है? क्या आपने सही तरीके से शाफ्ट सिंकिंग किया? तो चलिए देखते हैं शाफ्ट सिंकिंग करने के बाद के नतीजे। ओके, Okay, so cool it is. Now, this is your shaft. Okay. Now, as you are constructing the shaft, then in that case, this is your surface and this is your surface top. Okay. From here, you have made a headgear. Okay. Now, in this manner, in this manner, you have made the temporary lining like this. Now, the walls behind the temporary lining, there will be a gap between the temporary lining and the sides of the shaft. There will be a gap between the temporary lining and the sides of the shaft. Then these cavities which are created behind the planks will be filled with the help of the wood. Okay, blasting should be avoided in the area where temporary lining is necessary. So I have to remember all these things also. Now, if we talk about the temporary lining, then I will show you the exact picture of the temporary lining. As you can see over here, this is the exact picture of the temporary lining. Okay, so as you can see, this is a small portion, that means shaft is circular in shape but is cylindrical in shape. But we cannot show you the complete picture of it, but you have to make your imagination and just imagine you are just watching a portion of that circular shaft. The shaft is circular in shape like this, and you are just watching a portion of it, and that portion has the skeleton rings like this. As you can watch over here, these are the skeleton rings. Skeleton ring. Okay, as you can see over here, these are the skeleton rings. And after that, watch carefully, there is these are the wooden planks, wooden planks. Okay, salwood. And as you can see, this is a hanger. Okay, this is your hanger, this is your hanger. Okay, now if you want to see this hanger, then you have to just go to this side, that is near the shaft side. Okay, just you have to take your eyes near the shaft side, and on reaching the shaft sides, as you will see, this will look like this, in this manner. Okay, this hanger will look like this, that is, the hanger is in this shape. Okay, it is in this shape, and the skeleton rings are placed inside it. Skeleton rings are placed inside it. Okay, so are you able to imagine each and everything? So this is where your real imagination comes to reality. Okay, the imagination is coming to reality. That is, as you can see over here, these are the skeleton rings. These are the skeleton rings placed over here like this and in this manner from behind it. Okay, the sorry, skeleton rings. No, it's hangers. And okay, and these are the skeleton rings which are joined with the help of the fish plates or uh, overlapping. Okay, as you can see, this is your skeleton ring. Okay, this is your another for the bottom portion. This is another skeleton ring. In this manner, you can imagine all these things. Understood, everyone? Are you able to imagine about the hangers, skeleton rings, and this is the wooden planks? All these are the wooden planks. Okay. Are you able to imagine everything? Raise your hands. Not able to understand? Let me know if you are able to understand or not. Just have to raise your hands only. Okay. Now the next thing. After completing the temporary lining, we have to do the permanent lining. And when we will do the permanent lining, when your excavation reaches to the strong rock, then in that case the excavation is reduced to the finished dia of the shaft. Okay, whatever you have to keep the dia of the shaft, then that dia of the shaft is called the finished dia of the shaft. So if you reach, whenever you will reach the hard rock, then in that case you will limit your dia of the shaft, which will be equal to the uh, finished dia of the shaft, and for up to 3 to 4 meters below. Okay, for up to 3 to 4 meters below. After that, you have to do keep the your excavation up to finished dia of the shaft. Okay, after that the arrangement for the permanent lining is being done. Okay, after the excavation is done up to 3 to 4 meters depth, then you will do the arrangement for the permanent lining, that is the brick, concrete and the steel tubbing. Okay, brick, concrete and the steel tubbing as are being arranged for the permanent lining. Brick walling. Okay, now we will talk one after the other about all types of walling. This is the, if you want to do the permanent lining by the brick or with the help of the concrete or with the help of the steel tubbing. Okay, now first of all we will do the permanent lining with the help of the brick. So this brick walling, it is used in ordinarily compact and moderately wet strata basically. Okay, if you want to do the brick walling, then you can use it where you have to keep the compactness very ordinary, and the strata is moderately wet, not that much wet, then in that case you can use the brick walling. Okay, but for this purpose, which type of brick has to be used? The bricks must be the first class bricks which are well burnt, having the dimensions of the 225 in length, 115 in breadth, and the height must be 75 So this must be the dimensions of the bricks, and that bricks must be first class bricks which are well burnt. And the thickness of the lining in the case of brick walling must be 0.4 meter to 0.6 meter, and at the time of walling, sinking is usually stopped. Okay, when you are doing the brick walling, then in that at that time, so you have to stop the sinking. A 150 layer of concrete is then laid to form a level bed. Okay, level bed, the inside edge of the concrete being the finished dia of the shaft. Okay, in this manner you can do the permanent lining with the help of the brick walling. Okay, Now, after the concrete has been used, ठीक है। अब देखिए आपका यहाँ पर क्या होता है, आपको ब्रिक वॉलिंग करना है। सबसे पहले परमानेंट लाइनिंग करता है, ठीक है। परमानेंट लाइनिंग करते समय कैसे करते हैं, देखिए सबसे पहले तो क्या होता है, ये आपका सरफेस हो गया। जस्ट सपोज दैट दिस इज योर सरफेस, from the surface up to, just suppose that from the surface your strata has alluvium soil up to a depth of 5 meters. Okay, after reaching to the 5 meters, this is up to a depth of 5 meters. Okay, after reaching a depth of 5 meters, that is, you have completed your excavation in the alluvium soil of the or the soft soil, you have reached the hard rock. Now when you will reach the hard rock, you have to limit your excavation equal to the finished dia up to a depth of 3 to 4 meters. Okay, up to a depth of 3 to 4 meters you have to 3 meter, just suppose that 3 meter, up to depth of 3 meter you have done the, you have kept your radius dia of the shaft equal to the finished dia. Okay, after that you will make arrangements for the permanent lining, that is if you want to do the brick, है ना, आपको ब्रिक वॉलिंग करना है या कंक्रीट लाइनिंग करना है या स्टील टबिंग की मदद से आपको लाइनिंग करना है, तो आप इसकी व्यवस्थाएं बनाना स्टार्ट कर देंगे। अगर आपको ब्रिक वॉलिंग करना है तो आपका जो ऑर्डिनरी मतलब नॉर्मल सा कॉम्पैक्टनेस अगर आपको चाहिए, उतना ज्यादा कॉम्पैक्ट नहीं चाहिए, मतलब उतना ज्यादा मजबूत आपको नहीं चाहिए, आपको बस ऐसा चाहिए कि चलो थोड़ा बहुत पानी का सीपेज होता है तो वो इजीली सीपेज होते रहे, बाकी मुझे उतना मजबूत जो है तो लाइनिंग नहीं चाहिए, तो उस केस में आप ब्रिक वॉलिंग का इस्तेमाल कर सकते हैं, ठीक है। अब इसके लिए आपका क्या क्या बोलता है, अब आपको क्या बोलता है कि इसके लिए आप फर्स्ट क्लास ब्रिक्स का इस्तेमाल करें जो अच्छे से जले हुए हों, जिनकी लेंथ हो 225 mm, 115 mm ब्रेड्थ हो, हाइट हो 75 mm, ठीक है, और जो ब्रिक लाइनिंग आप कर रहे हो उसकी थिकनेस कम से कम 0.4 मीटर से लेके 0.6 मीटर तक होनी चाहिए। अब जैसे ही आप वॉलिंग स्टार्ट करते हैं, ब्रिक वॉलिंग का स्टार्ट करते हैं, तो उस केस में आप शाफ्ट सिंकिंग को यूजुअली रोक देते हैं, ठीक है, और 150 mm की थिकनेस की कंक्रीट लाइनिंग की जाती है। सबसे पहले क्या की जाती है 150 mm की थिकनेस की कंक्रीट लाइनिंग की जाती है। उसके बाद कास्ट आयरन का ब्रेकिंग कर्व लगाया जाता है, ठीक है, बोल्टिंग किया जाता है और जॉइंट्स में वेजेस की हेल्प से सपोर्ट किया जाता है और कर्व के ऊपर ब्रिक वॉलिंग कर दिया जाता है, ठीक है। as you can see over here in this manner। अब देखिए, अब आप बोलोगे कि सर कंक्रीट की लाइनिंग क्यों कर रहे हैं, देखिए सबसे पहले तो मुझे क्या करना है, मुझे ईंटे की जोड़ाई करनी है, ठीक है, आई हैव टू कीप ऑल द ब्रिक्स वन अबव द अदर, सो फॉर दैट पर्पस आई हैव टू डू अ कंक्रीट लाइनिंग making it as a base over which I will put all my basically all my bricks one over the other। Suppose that like in at home also, if you are making your house, then in that case first of all you will make a foundation which will be made of basically concrete, okay, after that you will make the beams also, okay, that beams are also made of concrete, okay, and again the pillars which you have to make it, okay, those pillars are also made up of the concrete, so in this manner you have made a structure that will provide or that will strengthen the brick wall, okay, then in that case also, so similarly over here while shaft sinking, if you are doing the brick walling, then you have to provide such an structure which will provide extra strength to the bricks, as well as they will help the bricks to stand at their position for a longer time, as well as until and unless they get dried up, okay, and hardened. Okay, for that purpose only we will provide here the concrete lining. Okay, the thickness of the concrete lining will be 150 mm. After making the concrete lining, we will use the cast iron, and okay, for the bricking curb. Okay, and that cast iron will be joined with the joints of the cast iron are being joined with the help by bolting. Okay, bolting is done to support the wedges. Okay, they are supported with the help of the wedges, and above that curb brick walling is done. Okay, let me help explain you with the help of the diagram. Suppose that this is your shaft. Okay, this is your shaft. Basically, you are doing the shaft sinking now. First of all, you will do a lining of concrete in this manner. This will help you to support the brick walling by reducing the water coming from the strata. Okay, okay. In this manner, you have completed the concrete lining. Clear? After the concrete lining is completed, you will place a curb like this. You will place a curb in this manner. After placing the curb, okay, after placing the curb, just suppose that as you can see, you have placed a curb like this. This is your curb. Okay, on this curb you will place your bricks. Okay, in this manner you will just place your bricks on these curves, so it will look like this. Okay, this will look like something like this. Clear? Okay, now there is a space between the there is a space between the this between the brick lining and the concrete lining. This space, this space, okay, this space is filled with the ash, sand, loose bricks. Okay, or I can say that this space is packed with the help of the ash, sand, loose bricks, and any extra material which you want to use it. Okay, now what is the reason we used to do the packing? Okay, why we do the packing? हम पैकिंग आखिर क्यों कर रहे हैं? कारण क्या है पैकिंग करने का? तो पैकिंग करने का मेन कारण क्या है? पैकिंग करने का मेन कारण क्या है? सबसे पहला कारण तो जो पैकिंग करने का है वो ये है कि आपका जो हाइड्रोस्टैटिक प्रेशर है, ठीक है, जो पानी, जैसे कि फॉर एग्जांपल हाइड्रोस्टैटिक प्रेशर मतलब कि आपका पानी के पार्टिकल्स, वाटर पार्टिकल्स गेट स्टोर्ड ओवर हियर because of the concrete lining. It will concrete lining will not allow to pass the water through it. Because of that, at some point of time this pressure will increase, and that pressure may affect your brick walling, okay, or the brick lining. So it should not get affected due to this hydrostatic pressure or the pressure generated by the particles of the water or the water. To resist such kind of pressure, basically packing is done. Okay, extra safety is also done. That means if such hydrostatic pressure is so much that it can damage the uh, brick walling, that means if it will increase or that pressure is too much high, then in that case the packing will not be able to resist it. So what are the other ways or the safety measures we can take? So in that case, weep holes are made. What do you mean by weep holes? Okay, weep holes are the holes which are drilled into the shaft side, or you can just imagine a pipe has been inserted into the shaft sides. Okay, just imagine I have taken a pipe and inserted into this wall. That pipe will not come out of the wall. Okay, this pipe will be inside the strata, and I will be able to just see the hole. It will be like a hole inside the परमानेंट लाइनिंग. ओके, अब हम क्या कर सकते हैं? देखिए, अब मैंने क्या किया, यहाँ पे हाइड्रोस्टैटिक प्रेशर इतना ज्यादा होता है, चूंकि कंक्रीट लाइनिंग किया वो ज्यादा होगा, तो उसका इफेक्ट किस पे पड़ेगा? ब्रिक वॉलिंग पे पड़ेगा. इसके लिए मैंने पैकिंग किया. लेकिन जब हाइड्रोस्टैटिक प्रेशर इतना खतरनाक है कि कंक्रीट लाइनिंग को, ब्रिक लाइनिंग को तोड़ सकता है, तो ये क्या पैकिंग किस काम का भाई साहब? कोई उतना मतलब का थोड़ी. एक समय के बाद तो ये भी काम करना बंद कर देगा. तो एक्स्ट्रा सेफ्टी फीचर के रूप में मैंने क्या प्रोवाइड किया? वीप होल्स. वीप होल्स क्या होते हैं? ऐसे होल्स जिन्हें हम शाफ्ट के साइड्स में ड्रिल बनाते हैं. जस्ट इमेजिन कि एक पाइप डाल दिया शाफ्ट के साइड्स में, शाफ्ट की दीवार में, वो पाइप हमें एक छेद की तरह दिखाई देती है, सांप के बिल की तरह दिखाई देती है. ठीक है, अब उस पाइप में से, अब वो पाइप जैसे ही आपने डाला, ठीक है, जस्ट इमेजिन, suppose that there is a pipe behind the, like this, in the brick walling. Okay, okay, the water will come out of the water from the surrounding will come into this pipe, as there is a less pressure zone, then it will come out like this. That's why it is called the weep holes. So, and when the water flows from the weep holes, then it will go to the water garland. Will not try to wet the whole shaft, because this may create काई. काई को इंग्लिश में क्या बोलते हैं यार? Algae on the shaft surface. That will be a much more dangerous for us. Okay, so, and they will consume oxygen also. Okay, why we used to not allow the water flowing directly downwards into the sump or at the shaft bottom. The reason for that is there will be the germination of the algae. So we used to make water garlands just below the, around the shaft, that will be just below the weep holes. The whole water will get collected into the water garland, and from there, from the water garland, there is a pipe which is connected to the bottom of the shaft. The whole water will go to the bottom of the shaft. So this is the complete method by which you can make your shaft. Okay, okay, so the pipe which is used for transporting the water from the water garland to the shaft bottom, the dia of that drain pipe is approximately 50 mm. Clear everyone? Do you want some rest? Does anyone want some rest? It is 10 o'clock already. Or should I continue? I have to complete the syllabus very quickly. Okay, I'm trying my level best so that you can understand also and complete the syllabus very best in a quick manner. Okay, so after 10:30, I will take the class. Okay, clear? Thank you, Sarma ji. After 10:30, I will take the class, next class. Okay, till then, all the best and thank you so much. Good night, everyone.
To watch the complete video, download Mining Gyan 2.0 app from the Play Store and enjoy seamless learning with Mining Gyan 2.0.